The growing use of AI and machine learning has led to a push for AI literacy, aiming to teach everybody the necessary knowledge and abilities required to engage with these new technologies. However, most tools for teaching machine learning in schools avoid engaging with the complexity and trade-offs inherent in the design of machine learning models, in favor of demonstrating the power and functionality of the technology. In this work, we suggest that a move to design is needed, and investigate the consequences of taking a design perspective on educational tools and activities. As the complexity and size of machine learning models increase to meet diverse challenges, so does the opaqueness.
The resulting lack of understanding of these models, combined with their pervasiveness and power, is deeply problematic for the people living in this machine learning-infused world. Since we're all users of machine learning systems, we should all have a say in how and when a system is beneficial, and to whom. This calls for a new, broad AI literacy which develops users' critical reflection and understanding of these systems.
One approach is to teach AI literacy in kindergarten to 12th grade education. However, existing popular tools for teaching K-12 students about machine learning and AI, such as Teachable Machine, Cosmo, and Machine Learning for Kids, sidestep the complexity and trade-offs inherent in the design of machine learning models, in favor of demonstrating the power and functionality of the technology. It enables students to explore the capabilities of machine learning systems, and even to use machine learning to design and construct their own systems, but rarely expose the complexity and difficult design questions and considerations in the process of constructing and deploying machine learning systems in the real world.
Therefore, as a complement to this demo approach, we contribute a framing of machine learning development as a design endeavor and explore the consequences of this for teaching machine learning in K-12 education.
We look towards the field of human-computer interaction and design to reframe how we engage with teaching machine learning and present the following 3 design considerations. First, taking a contextualized approach to the construction and evaluation of machine learning systems and considering the expected context of use. Second, exploring alternatives and emphasizing design rationales throughout the machine learning design process. And third, being mindful of how intentions are embedded in machine learning systems and reflecting on future implications. Next, we look towards the field of machine learning to understand how researchers in the field have described the process of designing machine learners. We use Enni and Assent's design model, which emphasizes how machine learners are designed around knowledge of the statistical relationship between input and output data, and how it requires not just computational thinking, but also design thinking to develop useful models.
The model consists of 8 separate components of the machine learner, which are all part of the machine learning project. The model furthermore articulates a set of design questions which are addressed implicitly or explicitly in the choices made for each of these components. And it invites reflection on how these choices impact the behavior of the resulting machine learning model. The questions emphasize how model design and evaluation must be understood with respect to its context of use, how choices and trade-offs are made in the particular design of the machine learner, and how desired behavior and relevant features are examples of intentionality being embedded into the design of the machine learner.
To investigate how the design perspective presented above can inform educational tools and activities for teaching machine learning at a K-12 level, we have conducted a systematic literature review. Using the design perspective and the machine learning design model, we review existing literature on activities and tools for teaching machine learning in general education. First, we examine which machine learning design components existing tools and activities engage students in. As can be seen in the table, overall, the analysis shows a tendency to emphasize the beginning and end of the machine learning design process, and less so on the inner components such as optimization objectives and learning algorithms. Next, we examine how existing tools and activities conceptualize the machine learning design questions linked to each component. Across all components in the design model, existing tools and activities mostly focus on demonstrating how machine learning is used and on creating the best performing model possible. While most papers focus on the different components from a technical, demonstrative point of view and skim over the social context and the decisions related to these, we do find some examples where choices about training data and data representation are contextualized, and where students explore alternatives. However, they are aware and do not emphasize the design rationales and intentions behind, nor the possible implications of the machine learning systems which students are engaged in constructing. On the other hand, the examples we found that did engage students in how machine learning systems intervened in existing social context and the ethical choices connected to implementing such systems, mostly did not engage students or engage them only to a limited degree in the inner components of machine learning systems.
Importantly, the design approach that we suggest is not a departure from the demo approach, but an addition. As numerous researchers have shown in the work we have reviewed, the approach is effective at teaching and at getting K-12 students excited about machine learning. But acknowledging that designing and developing machine learning systems is more than understanding and applying computational and mathematical concepts, but also includes engaging with complex socio-technical systems and making ethical choices, pose new challenges from an educational point of view. From a design perspective, all the components should be addressed with attention to these concerns, as they all include value judgments and choices that affect how the system is going to be used and how successful it is.
With our approach, we acknowledge that it is necessary to hide away or black box aspects of machine learning to not overwhelm students, and future work should engage with where to cut the cake, so to speak. We suggest that deciding on which part of the system to black box should be done with reference to a machine learning design model such as Enni and Assent's model. Educators and designers can reflectively choose which components they will explore in depth in a given learning activity, and use the design questions to engage with the remainder of the system to include the context and the bigger perspectives on the systems they are designing. Over time, students can learn about and explore the different components and the implications for the overall systems through multiple activities. To help educators and designers of educational tools and activities for teaching machine learning who want to apply this design perspective, we present a set of sensitizing concepts. The design-oriented approach favors reflexive engagement with the design of machine learning models over demonstrating their power and use, and thus it shifts focus from describing what a system does to reflecting on why and how this happens while suggesting alternatives. Rather than providing answers upfront, the design approach aims to ask questions that allow students to interrogate machine learning systems.
Rather than presenting machine learning as the solution to a given issue, the design approach asks students to explore said issue, to engage with trade-offs, and to reflect on the consequences of applying machine learning. Instead of presenting machine learning models as generic solutions to any given number of issues, the design approach suggests focusing on the contextual nature of machine learning models and on the many choices engineers and machine learning practitioners make on the ways.
Finally, instead of making machine learning easy by constructing scenarios in which success is a matter of improving performance, the approach suggests that teachers create scenarios that expose the complexity of the machine learning process and explore its limitations without overwhelming students with technical details.
We suggest a reflexive approach to teaching machine learning that empowers students to engage critically with it, to complement the commonly used demo approach that presents an uncritical and decontextualized view of the power of machine learning.
Through this strategy, the agenda of AI literacy, with its critical focus on engaging students in how technology form their everyday life, is more likely to succeed, as students participate directly in the design and deliberation of machine learning development, and thereby achieve the knowledge and perspectives necessary to engage critically with machine learning going forward. In summary, we propose a shift in the way we teach machine learning from demo to design.